Okay, this is section 4.2, day 2. We're filling in some more information about the unit circle and practicing with that. So we're going to get rolling right away. Make sure you have your unit circle sheet handy so you can be checking along as you're working today. So what we're going to do is try to figure out some different values using what we know about our special right triangles. And our big two questions are down here in the thought bubble. What's your reference angle and what's your quadrant? So being able to locate where those different values are. All right, so first of all, we're going to try this cosine of pi over 3. So we need to think about what pi over 3 means. Sometimes it's easier for people to think in degrees. Remember, pi is 180, so 180 divided by 3 is the same as 60 degrees. So our reference angle, or the angle that we're looking at to see how far are we away from the x-axis, is 60 degrees or pi over 3. So that means we can get the ratio from knowing that. So if we know what the cosine of 60 is, we're going to be able to figure out what this is. And the other part, to get the sine of our answer, so the reference angle tells us something about the ratio. What sign our answer is, that means like is it positive or negative, comes from what quadrant it's in. So 60 degrees is in quadrant 1, so we know everything is positive in quadrant 1. So our answer is going to be positive. So this is definitely going to be positive. Don't have to write the plus, just talking about it. And what is cosine of 60 degrees? Well, that is 1/2. So we know that the reference angle was 60. That told me it was a half. And it was in quadrant 1, so it told me it was positive. So that's kind of how we think these through. Let's take a look at a tangent. We can talk about that. So let's do 3 pi over 4, that angle. So the reference angle for 3 pi over 4, remember the reference angle is just this piece of it right here. So the reference angle is pi over 4. Pi over 4, remember pi is 180. So 180 divided by 4 is 45 degrees. So our reference angle is 45 degrees. So what we should be thinking then is what is the tangent of 45 degrees? It's going to have the same ratio answer as that. So let's think about that for a second. 45 is when sine and cosine are equal. X and Y are equal, so tangent is 1. So I know my ratio is going to be 1 for sure. Now we should have to think about quadrant. What quadrant are we in for 3 pi over 4? So 3 pi over 4 is 3 45s. That would be the same as 135 degrees. So 3 pi over 4, 135 degrees, that is in quadrant 2. So if it's in quadrant 2, what do we know about tangents in quadrant 2? Well, the y's are positive, the x's are negative. In other words, the signs are opposite. So that means the ratio is going to be negative. So tangent is negative in quadrant 2. So we know that the ratio is going to be 1 because that's the tangent of 45, but it's going to be negative because it's in quadrant 2. So being able to calculate these is really looking at what's the reference angle, how far am I from the x-axis, and then what's my quadrant. That'll tell me what sign it is. All right, let's take a look at this last one, and then we're going to do a few more. We're going to do a bunch of these today to kind of work through what we need to here. So cosecant. Now, first of all, if you have one that's not sine, cosine, or tangent, I would rewrite it as its reciprocal so we can think about the regular unit circle. So cosecant is the reciprocal of what function? Well, that's sine. So I'm going to do sine of 7 pi over 6 instead. And once I have my ratio answer for sine of 7 pi over 6, how would I find the cosecant? Well, they're reciprocal, so I'm just going to do the reciprocal of whatever my answer is for this. So let's figure out what my answer is for that first. All right, so let's talk about our two questions. First thing is reference angle. What would my reference angle be? So 7 pi over 6, I'm just looking at the pi over 6 part. And remember, pi is 180, so 180 divided by 6 is 30 degrees. So my reference angle is 30 degrees. So that means I'm going to be thinking, what is the sine of 30? And that's what the ratio is going to be for this one. And then we can figure out the quadrant for the sine. So sine of 30, that's the short leg, so that's 1/2. So we know what the ratio is going to be. It's for sure going to be a half. Now let's figure out what the sine of my answer is going to be by figuring out the quadrant. All right, so what quadrant is 7 pi over 6 in? So that's 7 times 30 degrees, or 210. So 210 degrees puts you in quadrant 3, or think of it as 7 pi over 6. So that's just past halfway, 30 degrees past halfway. So 7, 6, it's bigger than a whole. So quadrant 3, what do we know about signs? Well, they're negative, because x and y are both negative in quadrant 3. So when we think about those, it's a pretty easy way to be able to do that solving, because we know that that's going to give us a negative answer. So that would be a negative then 1/2. So we know that the ratio was a half because it was sine of 30, and it's negative because it's in quadrant 3. All right, so that's what sine of 7 pi over 6 is. Now remember what your question was, though. Originally it was cosecant. So if I know what the ratio is for sine, to find the ratio for cosecant, I just do the reciprocal. So if sine is negative of 1/2, that means cosecant would be -2. So anytime you get one of those reciprocal function ones, just do the original function first, and then you can flip. All right, let's take a look at a couple more here. So we're going to try to use the unit circle. These are examples in degrees now, so we'll start in degrees and do the same thing, same process. So we're going to use the unit circle to help us find the exact values of these functions. All right, so let's take a peek. We got cosine of 225. So reference angle and quadrant. So 225, how far is it from the x-axis? And again, pause these if you want to try them first and then take a look. That might help in your thinking. So the reference angle, that's 45 degrees. So we're 45 degrees away from the x-axis, which means my ratio is going to be the same as whatever the cosine of 45 is. And cosine of 45 is square root of 2/2. So I know for sure my answer is going to be a ratio of square root of 2/2. My second question is, what quadrant is it in? 225 is in quadrant 3, and I know in quadrant 3 all cosines are negative because you're going down, so it would be negative square root of 2/2. So if you know quadrant 1, if you know those reference angles in quadrant 1, that'll give you the ratio, and all you have to know then is where you are in the unit circle. Where am I in the quadrants to be able to find the rest? All right, how about sine of 315? It's going to be a similar answer. So let's talk about the reference angle first. So the reference angle, how far is 315 from 360? Well, that's 45 degrees again. So this is going to have the same answer as whatever the sine of 45 is. Well, sine of 45, same as cosine, so it's going to be square root of 2/2 again. But now we have to figure out, is it positive or negative? What quadrant are we in now? So 315 is in quadrant 4, which means if it's sine, it's y, and y is negative in quadrant 4. So this would also be negative square root of 2/2. So there's a lot of these that you're going to see similar answers because we're in the same locations. All right, let's talk about tangent of 180. Let's think about where 180 is. So we know it's halfway around the circle. So 180 is here. If we think about those values, remember tangent we think of as a slope. If you just look at the picture, if you're at 180 degrees, that's a horizontal line. What's the slope of a horizontal line? Well, that should be 0. So let's see if we can figure out why that's going to be 0. What's your reference angle? Well, if you're on the x-axis, your reference angle is 0 degrees. So this is going to have the same answer as the tangent of 0. Remember, tangent of 0, that's y over x is going to be 0. You didn't go up or down. The y value anywhere on the x-axis is 0. So that means at 180, it's still going to be 0. So if you can think about reference angle, that's not really in a quadrant. It doesn't have a sign because it's 0. So we can get that value pretty quickly. All right, let's try a few more. We're going to do some negative angles now. So negative, you just have to think we're going the other direction. Remember, counterclockwise, but it's still, what's my reference angle? What's my quadrant? So let's do sine of negative 135. So think about where that would be. So if you do negative 135, we're going to be right there. So think about what that reference angle would be then. So the reference angle, the distance between the terminal side and the x-axis. So the reference angle for that location is still 45 degrees. So I still need to do, what's the sine of 45? Which is square root of 2/2. But I just have to think about the quadrant then. And when you go in the negative direction, just be careful when you think about quadrant. How do I get to that location? Well, drawing the picture really helps. So I know I'm in quadrant 3. So if I'm in quadrant 3, that means my sign is negative. So it's a negative answer because y's would go down. So this would be a negative square root of 2/2. So the only consideration really that you have to be careful of when you do negative angles is just make sure you're thinking about the picture and that you end up in the right quadrant, because that's what tells you the sign of your answer. All right, let's try negative 240. So if I start at the positive x-axis, negative 240. So negative 180 would be halfway around. I've got to go another 60 degrees. That would be negative 240. So now we know where we're going to be. Let's talk about reference angle. So here's my reference angle. How much past did I go? Well, I went 60 degrees past. So my reference angle is 60 degrees. So that means I need to figure out what's the cosine of 60. And cosine of 60, that's, think about your unit circle there. Cosine of 60 is 1/2. So I know that my answer for sure is going to be 1/2. That's the ratio. Now I need to figure out what sign my answer is going to be though, positive or negative. So we ended up in quadrant 2. So if I'm in quadrant 2, what do we know about cosines or x's in quadrant 2? Well, if you're in quadrant 2, the x is going to be negative. Got a lot of negative answers today. That means it's going to be negative 1/2 then. So the ratio you always get from the SOHCAHTOA special right triangle, so your reference angle, your distance from the x-axis, that's where the ratio comes from. And your sign, the positive or negative, comes from the quadrant. All right, so one more in degrees here, 240, so for tangent. So think about 240. This is a positive 240 though. So think about that picture. So 240 degrees, that means you are 60 degrees past the x-axis. So our reference angle is 60. So if the reference angle is 60 degrees, that means we need to think, all right, what's the tangent of 60? So again, knowing that quadrant one super well. So 60 degrees bigger angle, that would be the bigger slope then. So that's the square root of 3. So I know for sure my answer is going to be root 3. Now the question is it positive or negative? Well, we're down here in quadrant 3. So thinking about that location, if we're in quadrant 3, what do we know about tangents? Well, since both x and y are negative in quadrant 3, that means tangent is positive. So when we look at our ratio, that's going to be positive square root of 3 then. So thinking about those values, it's going to have to be a positive number because it's in quadrant 3, so positive root 3. All right, let's finish up with a couple of the reciprocal ones. So cosecant, CSC, which one is that a reciprocal for? That's a reciprocal for sine. So this would be the same as sine of 60 degrees, but then we have to flip that, remember. So I always think about do the original function first, and then I do the reciprocal. All right, so remember we're doing, again, the sine of 60, and then we can flip that to find the cosecant. So 60 degrees, reference angle, sine of 60, that would be the longer leg then, so that would be square root of 3 over 2. That's definitely quadrant 1, thank goodness. So it's positive. So that means sine is square root of 3 over 2, cosecant would be 2 over root 3, and then we can rationalize that. So 2 root 3 over 3. Always easier to rationalize if we're going to work with a number. All right, secant's going to work very much the same way, but instead of reciprocal of sine, secant is the reciprocal of cosine. So I would be thinking, okay, what's the cosine of 30? So x over r, or we have our long leg for that one, square root of 3 over 2. Again, this is most definitely quadrant 1 because it's 30 degrees, but we still have to flip. So you end up getting 2 over root 3, or again, rationalize 2 root 3 over 3. So you actually end up with the same answer, which hopefully shouldn't be surprising because remember we talked about those co-functions of complementary angles are equal. So sine of 60 should always be the same as cosine of 30. So their secant and cosecant values would be the same as well. All right, we're going to finish up today with just talking about these functions in general, sine, cosine, making sure we know what kinds of answers should we always end up with. So we're going to talk a little bit about domain and range. Your assignment will be, though, what we just talked about, being able to do those values and find the reciprocals as well. So let's talk domain and range for a second. So domain means the x values, what values we can use. You can use any angle measurement you want. So the input for these, if you think about it, sine of an angle measurement is equal to some ratio for your answer, right? So that ratio that we get. So the domain value is always the angle measurement. So the domain is the angle. So I can use whatever angle I want, positive, negative, whole numbers, fractions, whatever. So the domain for sine is all real numbers. The range, though, the ratio that you get for your answer, remember this is y over r, or opposite over hypotenuse. The biggest number that can ever be, if you think about your unit circle, is 1, right? When the opposite side is the same length as the hypotenuse, like when you're up at 90 degrees, you can't have an opposite side that's more than the hypotenuse, right? The hypotenuse is always the longest. And then now remember we have direction as well. So not only can we go up, we could go down. So if you think about the unit circle, you can also go down to -1. But again, the hypotenuse is always the longest. So our range for this is going to be -1 to 1. Think about the unit circle, what those biggest values are. Cosine, the conversation is identical. They're the same domain and range. So -infinity to infinity and -1 to 1 for those ratios. So for these functions, we input an angle measurement, which can be anything. The output or the range is always going to be a ratio between -1 and 1. So the hypotenuse is always the longest. They cycle through. These are called periodic functions because the values keep cycling through. As you get bigger than 360, what ends up happening is you just repeat the same values again. You're going to go around. Think of all the angles that are coterminal. You end in the same location. You end up with the same sine and cosine values. So for example, if I say 390 degrees, gosh, that's the same as 30 degrees. So you're going to have all the same answers there. So they cycle. They're called periodic functions. So knowing something about that can help us when we're trying to figure out those values. So the period is actually the length of one complete cycle. before it starts repeating its values again. So for us, if you think about that, if you go around the unit circle once for sine, you hit all of the values. So that means that the length of one complete cycle for sine is 2 pi, or if you want to think in degrees, that's 360. Cosine is exactly the same thing. So as we go around the circle, we keep hitting the same values over and over and over again. So we can see what those values would be. So having this idea of repetition helps us see those angles that are bigger than 360 because we know those exist. And when we also talk about what their graphs are going to look like, we have talked about even and odd. Maybe you remember what symmetry they have. Because these things are repeating, you get pictures that look the same on both sides. So if you remember, even functions are the ones that have y-axis symmetry. If you remember, like y equals x squared, like a parabola, it's an even function, looks the same on one side of the y-axis as it does on the other. Because of this idea of repetition and periodic functions, cosine and secant are the ones that actually have, secant, have that symmetry. So they actually look the same on one side of the y-axis as they do on the other. They're considered even. Do you remember what symmetry odd functions have? Starts with an O. That was origin symmetry. So if you look at the graphs that we're going to talk about for our trig functions, the ones that are odd are actually sine, cosecant, so those reciprocals, and also tangent and cotangent. So all the other ones are odd functions, so they have origin symmetry. So it's kind of cool that we can relate what we did earlier in the year with symmetry. When we get into the graphs and we start talking about them, we'll see that they have those symmetries because they repeat, and you'll see that when we do that. So why do we need to understand period? Well, we can do things like this. Now we can do something like sine of 31 pi over 6, which seems astronomically huge. How are we ever going to do that? I'm actually going to start with the example on the bottom, though, because I want to do it in degrees first. I think that'll be a little bit easier to think through, and then we'll go back up to the one on the top. So how would you, so please add this one, cotangent of 600. Lots of things to unpack here. First of all, I wouldn't ever do cotangent. I'm going to talk about tangent. So we're going to do tangent of 600, figure out what that is, and then we can find its reciprocal. All right, so let's see if we can figure out our same two questions. So we still need to ask ourselves, what's my reference angle? So I need to do that. So what's my reference angle? And then what quadrant do I end up in? So the second question is what quadrant, which that's not even legible. Here we go. Quadrant. All right, so let's think about 300. Now the problem with 300 or 600 is that it's more than once around the unit circle. So we need to figure out a coterminal angle that's going to be easier for us to figure out what the reference angle is, the distance from the x-axis. So the idea is find a coterminal angle, something that ends in the same spot, because then you're going to have something that has the same reference angle. That's the whole idea with coterminals. They all share that same reference angle, so we know what our triangle will be. So let's find a coterminal angle. Remember how to do that? You either add or subtract 360. If it's radians, we add or subtract 2 pi. Since this is a positive angle, I'm going to go ahead and subtract 360 so I can get it down into something that I know, which is 240 degrees. So the answer for tangent of 600 is going to be exactly the same as the answer for tangent of 240 because they're coterminal angles. They end in the same spot. All right, so what's the reference angle for 240? Well, that's a 60-degree angle. So that means this is also going to have the same answer as whatever the tangent of 60 degrees is. So I can get all the way down to that reference angle and know what my value is going to be. So that would be square root of 3. Bigger angle, bigger ratio. So I know tangent of 600 is going to for sure be square root of 3. I just have to figure out the sign. All right, so where are you if you're at 240 or 600? What quadrant would you be in? So for 240, that's going to be down here in quadrant 3. If I graph 600, you just go all the way around the circle once and then 240 degrees. So we see that they end in the same location. So they're going to have the same triangle. So they're in quadrant 3. Tangents in quadrant 3 are positive. So that's going to tell me that this is a positive answer. So for sure, this is positive square root of 3. That's what the tangent is. Okay, so then how do I find cotangent? I just do the reciprocal. So it would be 1 over root 3 or rationalized square root of 3 over 3. So that idea of having something that's just bigger, okay, cool. Find something that's coterminal then to get it back into something that's more reasonable. All right, let's do that for a trig one as well, or not a radian one as well. So 31 pi over 6. So I still need to figure out what is that coterminal with. So to kind of start our conversation here, I'm going to figure out a coterminal angle for 31 pi over 6. Now that went all the way around the circle for sure more than once. So remember when we found coterminal for degrees, it was add or subtract um, 360. For this, we're going to add or subtract 2 pi. So I'm going to subtract 2 pi and see if I can get this down into something that I recognize. This is one option. We can leave it in radians. So think of it as 2 pi over 1, get a common denominator. So that would be 12 pi over 6. And then I can go ahead and subtract. So 31 pi over 6 minus 12 pi over 6 puts you at 19 pi over 6. Well, that's still too big. I got to subtract again. So I'm going to take 19 pi over 6. I'm going to go ahead and subtract 12 pi over 6 again. And we get down finally to something that I recognize, 7 pi over 6. So that works really well. We can figure out what this value is going to be. So the answer for this is going to be the same as the sine of 7 pi over 6, and I can do that conversation. If you don't want to work in radians, you could change this over into degrees. 31 times pi over 6 is 30 degrees. You could get that degree measure, so you could do it in degrees, and then you would be adding and subtracting 360. If that's easier, honestly, it doesn't really matter. You just have to know what your reference angle is. So one way or the other, we need a coterminal. All right, so I'm going to get rid of this so then we can talk about how do we find our ratio then? So we're doing sine of 7 pi over 6. That's the coterminal angle. So the reference angle then would be our pi over 6, or 30 degrees. So that means the answer for this is going to be whatever the sine of 30 is. And 30 degrees is our short leg, so 1/2. And we have to think about what quadrant we're in for the sine. So the quadrant for 7 pi over 6, think about what that would look like. So 7 pi over 6, that's the same as 210 degrees, so it's 1 past, so that would be 7 pi over 6. Actually, if you graph 31 pi over 6, it would be going all the way around the circle once, we went all the way around the circle twice, and then we ended up in quadrant 3. So this is a quadrant 3 angle. So quadrant 3 means for sine, we went down, so that's going to be negative. So our answer for 7 pi over 6 is negative 1/2. That means for our original, it's going to be the same thing. It's going to be that negative 1/2. So the key to all of this, everybody, is reference angle and quadrant. If you can figure out how far you are from the x-axis, then we can use those quadrant 1 SOHCAHTOA values, those quadrant 1 sine, cosine, and tangents, which we know really well. We got to get those memorized. But the quadrant, that's just knowing what signs things are going to be, and that usually works out pretty well. So that's the day 2. So what I'd like you to do is give a try those sine, cosine, and tangent values, and then we'll see how people are doing with the unit circle.